All right, guys, we're kind of doing a little bit of montage of lessons like I always do at the end of the year with Algebra 2. I try to put some things that are really on SAT, ACT, things that you'll see all around. So we will do all of Algebra 2 again, except the nitpicky stuff next year in pre-calc. But we are going to talk about arithmetic and geometric sequences. We are actually covering a little bit of lesson 11.2 and 11.3. Arithmetic and geometric, yes, you call it arithmetic, not arithmetic. Sequences, well, you guys know what sequences are. In arithmetic, if I have 3, 7, 11, 15, we are going up by 4. And I'm sure you all could see that on your own. If we have 4, oops, I'm trying to highlight, 4, -1, -6, -11, what are we doing there? We're adding a -5 because we're actually going down by 5. All right, what if we have 2, 4, 8, 16, 32, you will notice that these are being multiplied by 2. And then if we have 10 to -5 to 5 halves to -5 fourths, we never call it dividing. We're going to say that we are multiplying this by, I think, just by -1/2. Because we're dividing everything through by 2. So let's start with arithmetic sequences. Arithmetic sequences, this formula, they do not ever give it to you on an SAT or ACT. So I always write it on I have a thing called the New and Improved SAT, ACT cheat sheet, and this is on there. This is just one of those formulas. If you look at the night before you take an SAT or a PSAT, you're going to say, oh, I remember that. So this formula is for arithmetic. A sub n is equal to a sub 1, that is the first term of the sequence, plus, don't forget that plus, arithmetic, there is addition. In parentheses, n minus 1, that's the number of terms, minus 1, times d, which is the common difference. So let's look at example 1. Example 1 says, find the nth term of the arithmetic sequence. So if I have to find the nth term, we're going to write this with the nth term. So we don't know a sub n. We do know the first term is 7. We don't know the nth at all. And we know that if I look here, everything looks like it's just going up by 4, up by 4, up by 4. So we know that the common difference, the d, is 4. We do have to distribute this. So we have 7 plus 4n plus 4. Where my answer is, I'm running out of room, so I'm going to write my answer over here. The a sub n, the nth term, if I add like terms, is 4n plus 11. Now this is great because they're going to sometimes say, hey, find the 25th term. So instead of putting an n, I can just put 25 in right there for n. Okay, so this is kind of an example of what you'll see. All right, so moving on, now they're saying in example 2, let's find the 11th term. Find a sub 11. Anytime that's a down there, like going down to the right, that is a sub. So remember, we are going to put in, instead of putting in n, we are going to put in 11. 4 times 11 plus 11. 4 times 11 is 44, plus 11 is 55. So the 11th term of that sequence right there is 55. All right, we are going to move on to a little bit of a harder question. I'm going to have to use some different areas on my board because we don't have all this room. It says find the 20th, a sub 20, for the arithmetic sequence. So once again, we're using that sequence that I highlighted in yellow right there. Use the 20th term, find the 20th term for the arithmetic sequence in which a sub 2 is 13 and a sub 5 is 22. All right, so if we have to find this, we are going to set this up as a systems of equations. So let's use this area right here, and we're going to write this as a systems of equations. So the first thing that we need to know is that we know our formula, a sub n, is equal to a sub 1 plus n minus 1 times the common difference. The other thing that we know is that 13 is equal to, we don't know the first term, but we know that 13 was the second term. We also do not know the common difference. We know that 22 was the fifth term. And again, we don't know the common difference. So I set this up as a systems of equations. You'll see 13 is equal to a sub 1 plus, well, 2 minus 1 is 1. And then we have 22 is equal to a sub 1, well, 5 minus 1 is 4d. When I change all the signs, I'll change these to make it subtract nicely and add down. Well, these totally cancel out. 4 minus d is 3d, and 12 minus 13 is 9. So notice that the common difference is 3. So I know that the second term was 13. The common difference, we don't know. I should probably call these a sub 2. We don't know, but if I just go ahead and subtract 3, I know that the first term is 10. And again, the question says find the 20th term of the arithmetic sequence. So if I continue to solve all this, the first term is 10, the common difference is 3, and I can put all of this back into this equation to find the 20th term. A sub n is equal to 10 plus 20 minus 1 times the common difference. A sub n is equal to 10 plus, sorry, I forgot to put in the common difference there. Remember the common difference was 3. 19 times 3, which is 57. So 10 plus 57. And again, we're asking for the 20th term. The 20th term looks like it's 67. So that's how you would do the arithmetic sequences. All right, I'm going to throw a couple little concepts in here. The arithmetic mean, most of you guys know how to do this. Arithmetic mean just is finding the mean of two numbers. So you're literally just going to take these two numbers, add them, and divide by 2. When I add these, I get negative 4.2, and if I divide that by 2, the arithmetic mean is negative 2.1. Now, some of you have never heard of the geometric mean. This is one of those questions I see all the time on an SAT, ACT, and that's why I throw it into my curriculum. Just like the arithmetic mean was the average of two numbers being added, this is the average of two numbers being multiplied, but it's not just dividing by 2. Remember, to find the geometric mean, it is the square root of a times b. So I always tell my students, this is actually on my ACT, SAT new and improved cheat sheet. So we are actually finding the square root of 12 times 5. Well, 12 times 5 is 60. And I know that a 4 can come out of 6. So I know that 60 is 4 and 15. So the geometric mean is 2 root 5 here. All right, the last thing I need to show you guys is how to do geometric sequences. So this is the formula that you need for geometric sequences. I'm going to highlight it so you can see it. This is something they don't give you on an SAT, ACT, but guess what? They do show it. So this is one of those things that you want to have memorized. It is on my SAT, ACT cheat sheet. It's just one of those things, if you just look over it before you go in, you'll remember, oh yeah, we did that with Miss Maloney. The only thing that is a catcher on this one is notice that a sub 1 is being multiplied by r2, an exponent. Well, that exponent, remember order of operations, says parentheses exponents. So you have to keep that as is. So here we go. It says find the formula for the nth term of the geometric sequence. And then the next question says find a sub 6. So we're going to kind of do all this together. If I'm looking for the nth formula, our first term is going to be 81. So I'm going to find the nth formula here first. 81 times. R is called the common ratio. How do I find that common ratio? Well, let's think about it. If I was looking for the common ratio and I had 3, 9, 27, couldn't you just say these are multiplied by 3? And I also know I could take this 9 divided by 3 to give me that multiplication by 3. So I can take 54 and divide it by 81. Well, I know that 27 goes into each, so the common ratio is going to be 2/3. Sorry, I'm squeezing that in right there. So this is my common ratio. It's really just what's being multiplied. In this case, it's kind of a weird one, but 2/3 will go in the common ratio, and n-1 is the nth term. So this right here is the nth term of the geometric sequence. So now we have to go ahead and find a sub 6. A sub 6 is equal to 81 times 2 divided by 3 to the 6 minus 1. Now, you are a smart person. I know you probably are just going to throw this in your calculator, as am I, but I know that 6 minus 1 is 5, so 2/3 to the 5th power. Remember, you could put it in your calculator as you see it, using the parentheses just as you see them. So I would do that. But when you do find this answer is 32 divided by 3. All right, so let's look at one more just because we're here. I'm going to write the formula again. The formula is a sub n is equal to a sub 1 times r to the n-1. And this next question is going to say find, I don't know what example I'm on, I'll say 5. Find a sub 6 for 3, negative 12, 48, ... So we are looking for the 6th term. My first term is 3. So what are we doing to this to get to negative 12, to get to positive 48? We are multiplying by the common ratio of negative 4. And remember, we're finding the 6th term, so 6 minus 1. Again, I would just put this all in your calculator. And the answer is negative 3,072. How'd y'all do? I hope you guys are doing great with arithmetic and geometric sequences. I'm super proud of you and how you guys are doing with remote learning. If you need a separate Google Meet, please email me so that way we can go ahead and have a separate Google Meet. Great job, guys.